Assalamualaikum warahmatullahi wabarakatuh. This is Colvin Marine. Today we will see how to design a square microstrip patch antenna at an operational frequency of 5.8 GHz. So this is a square microstrip patch antenna, so the length and width of the substrate and ground will be same. So we first create the substrate. So for that, open a new file, a new template, new then go microwave and radio frequency and optical option, then antennas. Next, then this is a patch antenna, so this select this one. Then next, time domain, give it a time domain. Next, then give the dimension as the millimeter gigahertz like this. The next, so a frequency range, we need to set a frequency range. So our frequency is 5.8, so we'll make it 5 and 6 a range. Our frequency is between these two. So our frequency is 5.8. Finish. So it's coming. Now we will create the substrate. So we know the dimension of the substrate. As I mentioned before, the substrate, the dimension, the length and width of the substrate and ground will be 25. So we'll do that. For that, go to modeling, then take a break, then type step ESC on your keyboard, then name it substrate, substrate, then here we will use always variable, because when after the simulation when we need to change the dimension, so we will easily change from the parameter list. So here we will use always the variable. So the width of the substrate is, we'll use variable w minus w by minus is direction where it is going, x means w by 2 w by 2, then length L by 2. You can use this capital letter or small letter, that is not a big problem. L by 2 minus L by 2, y minimum minus L by 2. So here L by 2, L by 2. So the height, the thickness or height of the substrate would be minus s height minus h. So we will now set the material. The material will be dielectric material, whether it can be rogers or FR4. Here we will select FR4 roger, FR4, FR4 rosin. Here the absolute permittivity value is 4.3. We need this value while calculating the dimension of the page. So we need to remember this one, 4.3. Then load FR4. Okay. Then okay. So the width of the substrate is 25. They are asking for the value. So 25. Length of the substrate is 25 also because it is a square. Height is 1.6 gigahertz. Okay, then okay. Now you see here the substrate is, from the substrate The dimensions of the ground and substrate is same. So on the substrates we can easily create the ground plane. For that we need to select this one, this clean face, select it, then go this feature as extrude face, then make it now it ground plane, and ground plane, plane, ground plane. Then the height, use t thickness, height or thickness same, ground plane thickness preview. The ground plane thickness is 0.035. Okay, then okay, then okay. Here we made a mistake while setting the dimension. We did not change the material. So now what we can do is go component, select ground plane, then from this option you can change the material. Change material is ST level 4. The ground plane material should be conductor, whether it can be perfect conductor, PEC, copper, aluminum, whatever you want. But we are using here copper and lead load. Then okay, so it is changed. Now we will make the page. So for that we need to know the dimension of the page. To calculate the dimensions of the page, we can use an online tool. For that, go to any browser, but I'm going to Microsoft Edge. Here type pasta neck, NSCK, pasta neck. Okay, pasta neck. Then go through this website, go at the bottom, you will see calculator and converter. Click it, then come here and Microstrip Patch Antenna calculator. So directly constant. I told to remember the permittivity of the substrate. That value is needed here. So that is 4.3. Substrate direct substrate height is 1.6, not 0.035. 0.035 is the thickness of the ground plane. Here we need dielectric material. Dielectric is substrate, so here will be 1.6 the height of the substrate. Our here inches, so we need to change this unit. Millimeter changes to millimeter. Then operation frequency is 5.8. Then click calculate. So let's show you the weight of the page is 15.88 millimeter, length is 11.88 millimeter. Now we will make the page. So go to take another brick, square the noun page, page, use variable page of weight to page weight of the page to length of the page, LP by 2 minus is the direction, minus and LP by 2. Okay, then here will be thickness T, then CA preview, and the material is copper. Preview and the asking for dimension we got 15.88. Yeah, you can see weight is 15.88, length is 11.88. Okay, 15.88. Okay, then 11.88. Here you can see the preview of the page. Then okay, now we'll move this page a little above. For that, select the page and go transform feature, transform. Then you can move this page wherever you want. If you want to change this direction, you can change. If you want to change this direction, you can. If you want to change. Now we need to change it's above. So we'll change it above. Okay. No. Okay. For the better performance in microstrip patch antenna, they always cut a portion from the page near the feed line. So now we will cut this portion. For that, first we need to align the coordinate system. For that, go to here and select this. Okay, and then coordinate system is done. Now we will take another brick. We name it insert. Insert. So the weight will be the cut weight. We will cut it. So minus not minus WC by 2. WC by 2 length is 4 or 5, you can take whatever you want. Thickness, you need to set thickness T. See a preview, see always a preview. They are asking for the dimensions of the inside. It will be 5. So here you can see. Then okay. After that, cut this insert portion from the page. Select page and substrate, then insert, then enter. But we made a mistake while setting the dimensions of the insert. So again we will undo what we have done now. For that, type Ctrl Z or type this one. So we will type Ctrl Z and we can redo ever. So for that, go to insert and define brick and make this thickness minus T. Okay. Here we need to set 0. Let's see. Okay. Now we will cut this portion from the page. For that, what you need is select page and go boolean and substrate. What portion? Insert. Okay, then enter. Now you can see the insert portion is cut from the page. Now we will create the width line. Before creating width line, we must need to do impedance meshing. So how can we do impedance meshing? So for that we'll use the macros option, then calculate analytical impedance, thin microstrip patch line, then 5.8, our frequency is 5.8 GHz, the height 1.6, epsilon at 4.30, okay. So we'll see. Calculate. Okay. 64. We got our impedance must be 50. So it is 64. So we need to lower this value. To lower this value, we need to increase this width. So we will increase 30. Let's see what happens. Okay. So we get near 50. So we will also try to increase this one. 137. Okay. Exactly 50. We got exactly 50. So our the width of the fifth line will be 3.137. 3.137. What will be the dimension of the line? The value of the length of the fifth line. So to know the length of the fifth line, we can do one thing. So go to pick point here. Pick point is. Then also select this one. Then go to view. Then add dimension. This time. So now you can see 40 point. Remember this value 40.56. The length of the line is 3.6. So click ESC from your keyboard to remove this. Okay, to clear point, go to modeling and clear pick. Okay, now we need to align our coordinate system. So yeah, what we will do, this option and then do, okay, do this. So it is set, it is done. Now we will take another brick for the fifth line. Okay, then escape, then fifth line. This fifth line, our fifth line width will be what we got, 3.137. Okay, fifth we will use variable first. Fifth line width minus by 2. Fifth line width by 2. Then length is LF T. See a preview. The reason for the value W width is 3.137. Okay, and LF length is what we got, 40.56. Okay, they are showing above, so we will make it below. LF minus LF 0 below. Yes. So now, okay, now here again we made a mistake. This will be minus T 0. Okay, now we will add this to page and fifth line. Go boolean and add, and now it's all set. Now we can give input main prot. We can create port. For that we need to select the face of the feed line. For that, use this one, turn this and zoom, zoom. Select this face, pick face. Okay, then you can add the port automatically by using the macros. For that, go solver, solver port, and calculate port. Calculate it. Construct. No. Let's see. The port is, yeah. You can see. No, our design is done. No, we'll proceed with simulation process. So we'll go for that step of solver. Step of solver. Then start. Click on start. So our design is on simulation process. There you can see the progress is. As we can see, the simulation process is done. Now we will check the result. So first, one result, CS parameter. This parameter. Then you can see reference impedance, power, efficiencies, PSWR, FAPIL result, gain, directivity, many more. So here in this video I just try to show how to design a microstrip patch antenna, a Square Microstrip Patch Antenna at an operation frequency of 5.8 GHz. I did not care about the dimensions and was not specific about dimension. So when we will follow a specific paper, we will get the dimension, exact dimension from there. So my intention was just to show how to design a microstrip patch antenna at a frequency of 5.8 GHz. So that is all today. See you in next video. Assalamualaikum warahmatullahi wabarakatuh.